Hello student, good morning. I am Dr. Ajay Kumar Sinha, Professor of Chemistry. Today I am going to discuss methods of preparation of alkyl halide and aryl halide. First method is from alcohols. Alkyl halides are best prepared from alcohols, which are easily accessible. The hydroxyl group of an alkyl is replaced by halogen on reaction with concentrated halogen acid, phosphorus halides or thionyl chlorides. The hydroxyl group of an alcohol is replaced by halogen on reaction with concentrated halogen acids. Second, phosphorus halide or thionyl chloride. Thionyl chloride is preferred because the other two products are escapable gases. Hence the reactions gives pure alkyl halides. Phosphorus tribromide and triiodide are usually generated in situation C2 means SITU. C2 means produced in the reaction mixture by the reaction of red phosphorus with bromine and with iodine respectively. Phosphorus tribromide, I am talking about phosphorus tribromide and triiodide are usually generated in C2 by the reaction of red phosphorus with bromine and iodine respectively. The preparation of alkyl chloride is carried out either by passing dry hydrogen chloride gas through a solution of alcohol or by heating a solution of alcohol in concentrated aqueous acid. Reaction I am telling you. ROH. There is a bond between R and OH. O is attached with R, ROH. Then ROH plus HX. X may be fluoride, chloride, bromide, iodide. Then ROH plus HX. X is halogen. Then ROH plus HX. It will form RX plus water. Water means H2O. Then ROH, I told you bond is attached with R and OH. O is attached to R. Then this OH and HX means that H, that both will react. OH and H will react and it will form water. OH and H from HX, it will form water and X will join with R. Actually OH is negatively charged. OH hydroxyl ion negatively. X is also X is also negatively. Then in the place of OH, X goes easily. Substitution. Then here it forms RX plus H2O. Now second reaction, ROH plus NaBr, particular example sodium bromide plus H2SO4. Three reactants are there. ROH plus NaBr plus H2SO4. It forms three products. First product RBr, second product sodium bisulfate means NaHSO4 plus H2O. Then here easily it is forming ROH and NaBr in presence of H2SO4. Reaction is going on. Then very easily it will form RBr, and after that this it will form, because H2SO4 is there, NaHSO4, and one hydrogen from the H2SO4 that reacted with OH and it formed water. And in the place of one H, that Na came, Na plus from sodium bromide, that Na plus came in the place of H of H2SO4. One H used up in forming the water, OH plus H. Then one H, to compensate that one H was having 1 plus, H plus, that Na plus from NaBr came and it will form sodium bisulfate, NaHSO4. Now third reaction, 3ROH means 3 molecules of OH, ROH, 3 molecules of ROH plus px3, X means halogen, 3ROH plus px3. Then here you see px3, 3 X is 3, px3, and here 3ROH, 3R will be available, and here 3X is there, X3. Then it will form 3RX, and now 3OH is there. Then what will happen with this 3OH? Then this OH, 3OH, in that 3O is there, 3H is there, and in px3 P was there, then it will form H3PO3. One P was there with px3, then X3 used up, P was remaining. Then this P plus 3OH is there, 3H, 3O, hence it forms H3PO3, H3PO3. Here X is equal to Cl, maybe bromine. Now next example, particular example. Now ROH plus PCl5, phosphorus pentachloride, PCl5. Then here what will be the product? This is very important reaction. ROH plus PCl5. Then now again OH will be replaced by Cl and it will form RCl. Now 4 chloride is remaining. Out of 5 Cl, 1 is used up. Then now 1 phosphorus and 4 chloride is there, and OH is there. Then what will it form? Here phosphorus will convert to POCl3. 3 out of 4, now 3 used up, PO. 1 oxygen was there, that is also used, POCl3. POCl3, phosphorus oxide trichloride. And 1 Cl is remaining, 1 H is remaining. Hence it will form HCl. Hence final reaction, ROH plus PCl5, it gives 3 product, RCl plus POCl3 plus HCl. Now next reaction, ROH in presence of red phosphorus, and X2, maybe Cl, maybe Br. Then here ROH is there, then it will give Rx, because this X2 may be bromine and iodine. This particular reaction, X2 may be bromine, may be iodine. Then here that OH will be replaced with X, and it will give Rx. Main product is Rx. Okay, and other product will be that will be POCl3. Okay, that product will be there, POCl3, PI, and other product related to iodine here, but here is the bromine and iodine. Okay, then product will be of bromine and iodine with phosphorus. Now one more reaction I am telling you, that is the preparation ROH plus SOCl2, thionyl chloride, SOCl2, ROH plus SOCl2, it gives RCl. Here again OH is replaced by Cl. Okay, ROH plus SOCl2, it gives RCl plus SO2 plus HCl. 2 Cl was there, then 1 Cl went with R, and 1 Cl was remaining, that is attached with HCl, it formed HCl, and SO was there, only one O was there in SOCl2, but one more O from the OH. Now it formed SO2. Okay, then I have discussed main reactions of preparation. Okay, preparation from alcohol. The reactions of primary and secondary alcohols with HX requires the presence of a catalyst. Which type of catalyst? Then catalyst should be ZnCl2, zinc chloride. Okay. With tertiary alcohols, actually for the primary and secondary, for the reaction of primary and secondary alcohols with HX requires the catalyst like ZnCl2. And what for tertiary? With tertiary alcohol, the reaction is conducted by a simply shaking with concentrated HCl at room temperature. No catalyst. Question is asked. With tertiary alcohol, the reaction is conducted by simply shaking the concentrated HCl at room temperature. Constant boiling with HBr. HBr should be 48%. Constant boiling with HBr is used for preparing alkyl bromide. Good yield of Ri means iodide, ethyl iodide, may be obtained by heating alcohols with sodium or potassium with a given haloacid, and that is I am telling comparison. Tertiary is greater than secondary, secondary is greater than primary. Okay, the order of reactivity. This again you listen carefully, that I told you constant boiling with HBr is used. HBr should be 48%, is used for preparing alkyl bromide. Okay, and good yields of Ri means ethyl iodide may be obtained by heating alcohols with sodium or potassium iodide in 95% phosphoric acid. That time phosphoric acid is also required. That should be 95% phosphoric acid. Okay. The order of reactivity of alcohol. Now order of reactivity I am telling you. The order of reactivity of alcohol with a given halo acid. Halo means here halogen. That is tertiary is greater than secondary is greater than primary. And these methods what I discussed, this method is not applicable for the preparation of aryl halide, only for alkyl halide, not for aryl halide. Question is asked. Okay. Method again I am telling you because this question is asked. This is the important. Then here if you want Ri in more quantity, Ri ethyl iodide, if you want in more quantity, then this may be obtained by heating alcohols with sodium or potassium iodide and a phosphoric acid. This both should be present. Alcohol and sodium iodide or potassium iodide must be present in phosphoric acid. That should be 95%. Then order of reactivity of alcohols with given halo acid is tertiary is more than secondary is more than primary. Correct? The you can say method, but this method is not applicable for the preparation of aryl halide related to benzene. It is not benzyl chloride like this, chlorobenzene, bromobenzene. It will be not used. Okay. This is very, very important. Why it is not used? Because the carbon-oxygen bond in phenol has a partial double bond character and is difficult to break, being stronger than a single bond. This is the reason that in phenyl benzene ring, in phenyl, that is, you know, that is of the double bond character, then it is difficult to break the double bond character or double bond. Okay, that's why that can't be aryl halide can't be prepared by this method. Now other preparation I am telling you from hydrocarbons. Okay, first I told you from alcohol. From alcohols I told you many methods. I told you from alcohols. Now from hydrocarbon. And in this from hydrocarbons, here also you can tell different methods are there under hydrocarbons. From hydrocarbons, first is by free radical hydrogenation. Free radical hydrogenation. Free radical, you know that electron will be there. One electron will be there with radical. One electron. Okay. And this type free radical always will be very, very reactive. As for example, CH3. Suppose C2H6 was there. C-ethylene was there. CH3, CH3. Both C was joined with single bond. C and C single bond. Suppose it breaks. Generally, this type of bond breaks in presence of sunlight or UV light. Then the shared electron will be taken by both carbon 1,1. Both methyl group will take 1,1 electron. Then it will create two radical of methyl radical. This methyl radical will have 1 electron. Other methyl radical also will take 1 electron. Then this is the example of radical. Then these radicals are very, very reactive because now they are free. It is free. It can react with others, but generally it will react with other radicals, okay, to form the bond. Free radical chlorination or bromination of alkanes gives a complex mixture of isomeric mono and polyhaloalkanes, which is difficult to separate as pure compounds. Okay, free radical chlorination or bromination of alkanes gives a mixture, not separate, mixture of isomeric mono and polyhaloalkanes. Mixture of this will give, that is a mixture of isomeric mono and polyalkanes. This reaction gives a mixture of both isomeric mono and polyhaloalkanes, which is difficult to separate as pure compounds. Consequently, yield of any one compound is low. Then here reaction I am telling you that suppose this is there, butane is there, butane, okay, CH3, CH2, CH2, CH3, total 4 carbon, okay, CH3, CH2, CH2, CH3, and in presence of ultraviolet light, Cl will react, Cl2 chlorine gas will react in the presence of UV light, or if UV light is not there, then a strong heating. Then here what will happen? It will give two products. Both will be actually chloride only. Both will be chloride only, means alkyl halide, but both are isomers, means both are actually this butyl chloride only, but chlorine position, it will give two product, it will means two products it can give, okay, generally it gives mixture. Then here both are actually butyl chloride, but one product carbon in one product chloride will be at the first carbon, and in the second it will be on the second carbon. Then both are their structure, these are same, molecular mass is same, both are isomer, but where chlorine is attached with first carbon, that carbon is attached with only one carbon, means it is the primary chloride, okay, but here this other product chloride is attached with second carbon. Then here that carbon is attached with two neighboring carbon, one left side from the other right side, okay. Then this carbon is attached with two, then it will be secondary, means it will give, this reaction will give mixture of two, primary and secondary, primary butyl chloride and secondary butyl chloride. Now this under this from hydrocarbons, one method I told you from hydrocarbons. First I told you by free radical mechanism. Free radical means here, because UV light you have used, then this one bond actually one bond breaks. Okay, this CH3, last CH3 was there, last carbon CH3, then one H, C and H bond broken, and there one Cl came. Then here Cl2 was there, then first Cl2 will break, Cl, both will take one electron under UV light. Cl bond will break, both will be one electron will be there, then it will form two radical. Then this actually Cl one electron is there, two radicals are there, chloride radical or chlorine radical, you can tell, chlorine radical. Then one chlorine radical will come to the this near the CH3. That in butane that last carbon 3 hydrogen is there, CH3 or first and last same situation. Then that one bond CH, that bond due to this Cl radical, that bond will break. Then that will also, because it is a free radical, this bond, when this bond will break, it will create again a radical. Means C will have one electron, H will have one electron. Then C have one electron now, then Cl also have one electron, then both will join and it will form C-Cl bond between C and Cl. This is actually called free radical mechanism, because bond formed through radical. Then now this H radical, what will happen to this H radical? Now H has one electron and is very reactive. Then now Cl2 broken, that time two radical it formed, Cl2, Cl, one used up, then one Cl was remaining, one radical. Then that one radical and hydrogen one radical, hydrogen radical and that Cl radical, both joined and it will form HCl. This is the mechanism I told you. Okay, this is a side product. Then here main product is there, that with first carbon CH bond can break, one possibility is second probability is that second bond, a second carbon second, from that also two H is attached, there also same thing may happen, two possibilities are there. Then that situation also Cl will add there, C and Cl will make bond and H will be removed, having one radical, that will react with the free chlorine radical. Again it will form HCl. Then two possibilities are there, it can join at carbon 1 also and carbon 2 also. Hence you will get mixture of both. Now second I am telling you, this also is from hydrocarbon. Then here it is by electrophilic substitution. By electrophilic substitution. Now substitution means, you know, same thing, one will go and other will come in its place. That is actually substitution. One will go and its place other will come. But now I told you there are two type of substitution. Okay, nucleophilic and electrophilic. Then Nu, it is a nucleophilic is nucleophilic substitution, that is represented by Nu, 1 minus. Okay, one pair of electron will be there, 1 minus you can tell. This is the representation for nucleophile, and just opposite to this electrophile, it will have positive charge. E means electrophile and E will have positive charge. And now you can see that is the electrophilic substitution. Because substitution is going on, then it is clear E is a positive. Then it will substitute the positive only in a nucleophilic substitution. That was having negative. The negative will be substituted by negative. correct? Here E plus is there, plus, then E plus will be getting substituted by plus only, okay, plus only. Now you see here a reaction. Aryl chloride means a phenyl chloride also you can tell, benzene. Aryl chloride or chlorobenzene, like that you can tell. Aryl chloride or bromides can be easily prepared by electrophilic substitution of arenes with chlorine and bromine respectively in the presence of Lewis acid catalyst like iron or iron third chloride, FeCl3, iron third chloride. Iron may be iron chloride means here iron third chloride. Then here now you can see that aryl chloride how you will prepare by electrophilic substitution, electrophilic. Then here you can start with toluene. One CH3 is attached with benzene, and here this toluene plus X2 means maybe Cl2, maybe Br2, maybe I2, like that way. X is equal to F, maybe Cl, maybe Br, maybe I. Then this toluene means with benzene one methyl group is attached plus X2. This reaction will take place in presence of iron chloride, means iron should be in the third oxidation state, 3 Fe3, or this reaction will take place in dark. This reaction takes place in dark, not in the daytime, light, dark. Then what will happen here? That reaction is Iitjee. That one methyl group is already attached. Then now where will this X2 will give X, X2 that will break into 2X. Okay, but here you can see what will happen. And here you should understand X2 means, as for example Cl2 is there. Then when it breaks Cl, the what will be the charge? Cl it is not radical. This time you will not get radical. And what will happen? One Cl will be positive and other Cl will be negative. This will happen due to catalyst. Okay, presence of ferrous chloride. Due to that it will break, Cl2 will break, then one Cl will be positive nature, other Cl will be negative nature. One will take electrons. Then now that one will be negative, other Cl will be negative, other will be positive. Okay, now you can understand very easily. Then here what will happen? Then now in benzene you know that every carbon have one H. One H is already replaced with methyl group, toluene I told you. Then now 5 carbons are there, and from each carbon one hydrogen is attached. Then now consider that one carbon, and in that carbon also H is there. Then that H will go now. That H will go as H plus. As H plus it will go. Okay. And there in the place of that H plus, Cl, what I told, Cl plus was there. That here actually it will go as a H plus. From the carbon one H gone, that is leaving its electron, it gone as a H plus. Then carbon is a negative. Then now here Cl will come, which has positive Cl, that will come here. Means H plus gone, and in its place Cl plus is coming. Cl plus is coming. That's why it is electrophilic substitution. Electrophilic substitution. H went as H plus, and its place Cl plus has come, and carbon has negative charge. Then this Cl plus easily can make bond there, because that carbon will give electron to the Cl plus and bond will be formed. Then this H plus, now where it will go? Then it will go to the Cl minus, and that Cl has electron, that it will give to the hydrogen, because it has no electron, H plus. Then it will form HCl. Then here two possibilities are there. This with respect to methyl group, it can make bond with ortho position, and also it can make bond with para position. Both position possibilities there. Hence it will give the mixture of two. Means it will give ortho halotoluene. Ortho position, halogen attached. Then ortho halotoluene. Halo means here halogen. X is halogen. Okay. Then ortho halotoluene, and other product will be para position, para halotoluene. Both mixture you will get. The ortho and para isomers can be easily separated. You can separate it both. Easily can be separated. How? The ortho and para isomers can be easily separated due to large difference in their melting point. Melting point difference is more. Reactions with iodine are reversible. Here it is a problem. Reactions with iodine are reversible in nature and require the presence of an oxidizing agent like HNO3 HiO4. Okay, to oxidize the Hi formed during iodination. Correct, because reaction is reversible. Again same product you will get. Then Hi, as soon as Hi it is forming, that must be removed. Otherwise again it will go and previous product you will get, because reaction is reversible. And this one should be very this things alert when you are using iodine, because reaction with iodine are reversible in nature and require the presence of an oxidizing agent. Oxidizing agent example may here, that is maybe HNO3 nitric acid or HiO4, or both may be present there. Okay, HNO3 and HiO4. What it will do? That it will oxidize the Hi formed during iodination. Fluoro compounds are not prepared by this method. Question is asked. Both question is asked. Why oxidizing agent is required here during this thing iodination? Then this question is asked. And second, this why fluoro compounds are not prepared by this method. Then this is these fluoro compounds are not prepared by this method due to high reactivity of fluorine. Due to high reactivity of fluorine. This question is also asked. Now, under this hydrocarbons, from hydrocarbons, third method is Sand-Meyer's reaction. Sand-Meyer's reaction. What is this Sand-Meyer's reaction? Then I am telling you now. When a primary aromatic amine dissolved or suspended in cold aqueous mineral acid is treated with sodium nitrite, a diazonium salt is formed. This is very, very important. Diazonium salt is formed. Again I am telling you, when a primary aromatic amine dissolved or suspended in cold aqueous mineral acid is treated with sodium nitrite, a diazonium salt is formed. Mixing the solution of freshly prepared diazonium salt with cuprous chloride or cuprous bromide results in the replacement of the diazonium group by Cl or Br. Okay, here it is important. Correct? This diazonium salt you got, diazonium salt you got means N2X actually it forms N2X. Then N2X, N2 will have a plus because here nitrogen will lose lone pair of electron. That's why it becomes plus. And that electron will be given to whom? Then it will be given to Cl, X. Then on nitrogen N2 1 plus will be there, on X 1 minus will be there. N2X is called diazonium group, N2 plus. Then here aniline means on benzene one NH2 group is there, aniline. Okay. This is actually primary because this nitrogen is attached with only one carbon. That's why it is called primary aromatic amine. Okay. And this primary aromatic amine that was dissolved in mineral acid, and that now amine you are treating with sodium nitrite NaNO2 plus HX, because HX will provide X, and temperature you have to maintain 273 to 278 Kelvin. Then now what will happen? NH2 is there. NH2 is there on benzene. Then now there only what will happen? Here you want to introduce X. Then it will not go and directly and ClX will attached. It will go through benzene diazonium. But it will form by this benzene diazonium halide, means Na2 plus HX. It will form that NH2 was there, that will convert into N2X. Then N2 will have positive charge, X will have negative charge. Now question arises, how, here you have to understand how NH2 converted into N plus. N2 plus, how did it form? NH2 how converted into X? That you have to understand. Reaction is not so simple. Then here you can see 2 hydrogen is there. NH2 2 hydrogen is there. Then both hydrogen should go out to form N2X. Then here 2 hydrogen is going outside. Both are plus plus, H plus, H plus. And nitrogen has taken its electron. 2 electron it has taken. Then now what will happen? That NaNO2 is there. Means 2 oxygen is there. 2 oxygen is there. Then total number of hydrogen, how many are there? Then NH2, 2 hydrogen plus with HX. With HX, 1 hydrogen is there. 3 hydrogen is there. Correct? And Na plus is also there. NaNO2 is there. Then Na1 plus is there. Means total 4 positive charges is there. 3 due to 3H, H plus, 3H plus, and 1 positive charge due to Na1 plus, sodium. Means total 4 positive charge. And now oxygen is 2 oxygen. Then here what will happen? What will it form? Then now we can see that 2 oxygen is there and 4 positive charge is there. Then it will form NaOH. Then 1 oxygen used up, 1 hydrogen used up. Then now how many are remaining? Then 2H is remaining and 1 oxygen is remaining. 2H and 1 oxygen is remaining. It will form water. Correct? 2H, 1 oxygen. H are positive, oxygen is negative, you know. It will form water. Then means side product, first I am telling you NaOH and H2O. Then now you can see that when Na gone from Na2, from NaNO2, Na gone outside, then N will have negative charge. NO2 is 1 negative. Correct? And here oxygen also that NO2 is there, then N and O bond will break. Then oxygen is more electronegative. It will go with electron only. It will attract the electron of nitrogen. Then nitrogen will be positive charge. Then this nitrogen now which has positive charge, here it will go to the, here NH2 was there, then H2 went as H plus, leaving the nitrogen, hydrogen went, leaving the distance electron, hydrogen gone as a H plus, and its electron was with nitrogen. Then the nitrogen was having negative charge. Hydrogen electron is with nitrogen. The nitrogen is negative charge. But this nitrogen from NO2, that nitrogen is positive charge. Then now this nitrogen negative charge, that nitrogen positive charge, they will make bond N2. N2 bond is formed. Now N2 bond is formed. Then after that what will happen? That now think for the HX. H already gone. X minus is there. Then this X minus that require positive. It will go to the positive because X is negative. Then for the stability it require positive. Then it will come to the here N2, and N2 is here this things. First nitrogen has a lone pair of electron also. Correct? And it is positive also. Okay, because 2 hydrogen gone. That time actually they just H plus, they went as H plus, then it was nitrogen having electron. That electron is given to another N which was positive. Okay, then N2 formed, and when X minus will come to the this N2, then actually this N2 will give the lone pair of electron to X. This X is the minus, already minus is there. Okay, then here positive charge nitrogen actually here this Cl minus, because they have given electron to the nitrogen, correct? Then due to that nitrogen became NH2 nitrogen. Now it is a somewhat positive character, correct? positive character, and this, due to this is positive character, here you can say first N2 bond is formed. Then now this actually here Na-NO2, when bond was broken, then that N was having, that time N was having these things, Na went leaving the electron, then that time N was negative, and their negative charge, that oxygen is electronegative, that had taken, correct. Then here nitrogen got positive charge, correct, positive charge. Then now this actually, this nitrogen, not the first nitrogen, NH2, not that, and that second nitrogen is a positive, okay, positive. Then X will attach to the second nitrogen, okay. Then now X made bond there, then it form N2X, okay. Then here you have to understand that NO2 is first Na is losing as a Na plus, and that electron is with N, and oxygen is NO2, that will leave, that time oxygen will take the electron, then it will go. Then nitrogen will be positive because two bond is breaking, okay. Then positive character will be with this nitrogen, okay. This positive character will be there because two oxygen is taking electron and going. Then more electron it lost, then positive charge is there with this nitrogen, okay. And this, with this nitrogen only X will come. X is negative charge, it will attach here, NX, correct. And this N now will join with here NH2 bond, there is negative NH2 benzene, I am talking about this aniline, that was actually negative. Then that will join with N, NO2N, okay. Then this N is negative charge, that will give to the N of NO2, correct. That was positive character, that's why NO2N, which was, because it was a positive character, that's why it balanced the X minus also, and N was having from the this aniline, that N, that was also negative, X was also negative, it was sufficient, okay. Then it made bond with N as a N2 plus, and X has X which was having minus, just that came, and X has given electron to the N2, or we can say positive is neutralized by negative, okay. Then it formed N2X, okay. N2X just like a salt, that's why it is called diazonium salt, correct. N2 was having positive charge, X is negative charge. Then this N2X is attached with benzene, that's why it is called benzene diazonium salt. But here X is halide, then it is called benzene diazonium halide. Halide may be chloride, bromide, iodide, etc. Then now this by forming benzene diazonium halide, I told you how it formed. Now actually your intention is to get the directly X should attach to the benzene, that is our intention, and N2X should go, and its place X should come, correct. Then now this N2X formed, benzene diazonium halide formed, that in the presence of Cu2X, cuprous halide, what will it do? That you think? Actually, now here that this bond will break. Carbon and N2X bond is there, diazonium halide bond. Then carbon and a nitrogen, that bond will break. And this N2 and X bond is there in diazonium halide, that N2X bond will also break. Then N2 will be free. N2 will be free nitrogen gas. It will go as a nitrogen gas. Correct? Then now what will happen? That it will go. Nitrogen gas will go. Then here, because N2 gas, it is going. Then at that carbon, actually this carbon is a positive charge. That carbon, because nitrogen is electronegative nature, then it will go with electron, because N2 was having positive charge. It requires electron. Then this carbon has given electron to nitrogen. Correct? Then now this carbon has become positive and nitrogen became neutral. It went as a nitrogen gas. Now leaving the carbon positive. Then now X is minus. That electron will be given to the carbon and they will form bond, direct bond CX. CX bond will be formed, means aryl halide. X may be chlorine, X may be bromine. Then here final reaction I am telling you, that this benzenium diazonium halide in presence of Cu2x2 cuprous halide, that it will give aryl halide plus N2. What will happen? I told you that carbon and N2 bond will break and other bond also will break, that is the N2 and X bond will break. Then N2 will be free as a nitrogen gas and it will go with electron. Then carbon will be what? Positive. Then but X is of negative, and that X will join with carbon and bond will be formed. Okay. Then this is called actually Sandmeyer's reaction. Here Sandmeyer in reaction means important thing that it forms a benzene diazonium halide. Okay, benzene diazonium salt forms. That is the main things of this reaction, Sandmeyer reaction. Now further I am telling you, replacement of diazonium group by iodine does not require the presence of cuprous halide. Okay, means for the chloride it is required. For the bromide it is required Cu2x2. Okay, and for this iodine, if you want to, you can say this iodine should be attached there. Iodobenzene, suppose you want, and for that time this cuprous halide is not required. Okay, does not require the presence of cuprous halide and is done simply by shaking the diazonium salt with potassium iodide. Okay, this is the means reaction. You can write simply that these things benzene N2X by diazonium salt is there, benzene diazonium salt plus Ki, directly I will be introduced to the benzene with carbon. They will make with carbon I, and iodobenzene will be just like chlorobenzene, bromobenzene, fluorobenzene. It is iodobenzene will be formed and nitrogen gas will be liberated. Okay. Now next reaction is from alkenes. That is actually hydrocarbon. All are coming under hydrocarbon from alkene. Okay. How? Then it is very easy to form from alkene is double bond, you know. And you want to introduce iodine. Okay. I want to introduce. Means any halide you want to introduce. Then addition of hydrogen halide. Means take the example of ethylene plus HX. Then very simple thing is that this double bond out of two, one bond will break. Then actually out of this two bond, one is a sigma bond, other is a pi bond. Then pi bond is weaker than sigma bond. Hence only pi bond will break. Correct? Pi bond will break. Then this will give 2 electron. Okay, when bond will break, because for one bond 2 electron is required. Then each will take one electron. Or you can tell if both electron is taken by the one carbon, then other will be negative. Other carbon will be negative. Equal they will take only when a bond is breaking in presence of sunlight. That time they will take one electron. But if it is not under the sunlight or UV light, then any one carbon will take both electron. That depends upon from that carbon what are the other group is attached. If that group wants electron, then electron will be taken by that carbon only. Correct? Then other will be positive character. Means one carbon will have positive, other will be negative. Then ethylene, if bond breaks, one carbon gets positive charge, other carbon gets negative charge. Then HCl. Suppose HX is going to addition. Then H will have positive, X will have negative. Then it will go to the opposite charge. Means plus will go to the minus. Means Cl minus. That will go to the minus. Chloride ion will go to the carbon which have positive charge. And H is positive. Then it will go to the carbon which has negative charge. Because that negative carbon will give electron to the H. Correct? And here other carbon, it is lacking behind, it is a positive character, then Cl will give the electron. Cl means halogen will give the electron. Then it will form H and Cl. Both will attach with 2 carbons. Correct? With 2 carbons. At one carbon H and at other carbon Cl will attach. And double bond will become single bond. Then addition of hydrogen halide. Here what happened I have discussed. Here again I want to brief you. An alkene is converted to corresponding alkyl halide by reaction with hydrogen chloride, hydrogen bromide or hydrogen iodide. HCl, HBr, HI, whatever be. That is in general way HX. Then it will join H and X. Then it will called already suppose one carbon CH2 was there. Then now new H will add there. Then at one carbon 3 hydrogen will be there. 2 was already. Now new hydrogen. 3 hydrogen. And in other carbon 2 hydrogen was there. Now X has joined. But both should be adjacent. H and X will join with the adjacent carbon. Where bond broken, only that 2 carbon. Okay, this is important. Propene I am talking about. Other example, propene example I am giving you. Propene, 3 carbons are there. Then out of 3, one double bond will be there. For first and second will have double bond. And other bond will be single bond. Then here reaction will take place with double bond, not with single. Okay, propene yields 2 products. propene yields two products. However, only one predominates. Out of two, only one predominates by following the Markovnikov's rule. Okay, Markovnikov's rule already I have discussed. Means here CH3CH, double bond CH2. This is the propylene or propene, you can tell, propene. CH3, and after that second carbon CH, and third carbon is CH2, and in between the two double bond is there. Means second and third double bond is there. Then obviously that first carbon 3 hydrogen, second carbon, because double bond is there, then now 3 bond is total, double bond plus 1 bond with methyl, then 1 hydrogen is only required. And here last carbon 2 bond is there, then 2 hydrogen is required. Then suppose HI is adding, then major product will be what? Actually Markovnik rule is that only H will go to that carbon which has more hydrogen. Hydrogen will go to that carbon which has more hydrogen. Then here double bond, one is CH, other is CH2. Then HI, suppose you wants to add, then this H from HI will just go to the CH2. CH2 means 2 hydrogen is there, and other has only 1 hydrogen. Hence H will go to the more hydrogen carbon. Okay, carbon which has more hydrogen means CH2. Now it becomes CH3, and with CH, Cl will join, I will join. HI is there, I will join, and this will be the major product. CH3, CHI, CH3, CH3, CHI, CH3. This is according to the Markovnikov rule. Okay, Markovnikov rule. And one product is also possible that will form opposite to that. Means now I will go to the where more hydrogen is there, that side. Then here in this time reverse case will be there. I will go to that carbon which has more hydrogen, and H will go that carbon which has less hydrogen. This is the minor product, less product. Main product is that Markovnikov. You remember, H will go to the more hydrogen, carbon which has more hydrogen. Only one thing you remember, otherwise you will get confused. Okay. Markovnikov rule is very easy, that hydrogen will join to that carbon which has more hydrogen, simply. And Karask rule is there. There case will be reversed, what I told with minor. But this require peroxide H2O2. A special condition is required. Only then this will go to opposite. Otherwise, Markovnikov, that hydrogen will go to the carbon which has more hydrogen. Okay, reverse case is possible in Karask effect, and for that condition is there peroxide. Correct? Remember it. It is very, very important. Now this example I am telling, suppose Bre2 is there, bromine is there, and direct ethylene is there. Ethylene. Actually in the laboratory I am talking about. In the laboratory, addition of bromine in presence of CCl4 to an alkene results in discharge of reddish brown color of bromine, constitute an important method for detection of double bond in molecule. This is very, very important. Question is asked. Addition of halogen means here in bromine I am talking about. In case of ethylene, suppose you want to know whether double bond is there or single bond is there, if you want to check it, test it, that time this reaction is done. In the laboratory, addition of bromine in CCl4 means carbon tetrachloride, addition of bromine to an alkene, but this reaction will take place in presence of CCl4. CCl4 is used as a solvent, just like water. Then what will happen? Addition of bromine to an alkene, resulting in discharging of reddish brown color. It will give a reddish brown color of bromine. Constitutes an important method for detection of double bond in a molecule. The addition results in the synthesis of vis dibromide. Vicinal dibromide will react, means that both carbon will take 1,1 chloride bromine. 1,1 bromine, each bond will break, and here Br2 is there. Then here I told you one carbon will, any one will take electron, other then it will be negative, other will be positive. Then Br2 again same case. Br will break, one will be positive, other will be negative. Then it will join with opposite, means negative bromide will join with positive, positive will join with negative. Hence it will give vicinal dibromide, means adjacent, not in the same, adjacent, correct. And this color I am talking about, discharge of reddish brown color, that is the test of double bond. Bromine is actually reddish color, but if reddish, because bromine is used up, hence there will be no red color, that is called discharge of red color. Bromine is used up, that is called discharge of reddish brown color of bromine. This constitutes an important method for detection of double bond in a molecule. Wherever in other also, if double bond is there, then bromine will, when will it used, then bromine red color will go from the solution. Then red color going means bromine joined, and bromine joined means red color will finish, there is no red color. Then that will tell about that actually it will join at only a double bond. Hence it means that molecule was having double bond, like ethylene or propylene also. This I have discussed about the these things, preparation, okay, preparation from this thing, hydrocarbon, preparation from hydrocarbon. Okay, now next class I will discuss these things, halogen exchange. That is actually also easy. Let me discuss only one is there. The next class I will discuss physical properties. One reaction is there, that also I want to finish. Then properties I will discuss next class. Halogen exchange. Halogen exchange. Halogen exchange. What will happen here? My name it is clear. Halogen will be exchanged. Alkyl iodide are often prepared by the reaction of alkyl chloride or alkyl bromide. This alkyl iodide, if you want alkyl iodide, then alkyl iodide are often prepared by the reaction of alkyl chloride or alkyl bromide with NaI. Very simple way, means from the this thing chloride, NaI plus NaI you have to use react. Then alkyl iodide are prepared by the reaction of alkyl chloride or alkyl bromide with NaI in dry acetone. This reaction is known as what? This important reaction, Finkel-Stein reaction. Finkel, Finkel, Finkel Stein, Stein. Question is asked. Finkel Stein reaction means Rx plus NaI, Rx plus NaI. Then X is also negative, I is also negative. Then it is going to be exchanged. It will form Ri plus NaX. Rx was there, X gone, I came its place, it formed Ri, and that X went with sodium, it formed NaX. Here X may be chlorine, may be bromine, Cl, Br. Okay, X may be Cl, X may be Br. NaCl or NaBr thus formed is precipitated in dry acetone. Precipitated means you can filter it. It facilitates the forward reaction according to Le-Chatelier principle. Means product will precipitate it, you can filter quickly. Okay, forward reaction means it will give Ri that you can separate it. It will give precipitate. So now solvent is acetone. The synthesis of alkyl fluoride. The synthesis of alkyl fluoride is best accomplished by heating an alkyl chloride or alkyl bromide in the presence of metallic fluoride such as silver fluoride HAgF, mercury fluoride Hg2F2, cobalt fluoride cobalt F2 or antimony F3. Okay, all are fluoride only, silver fluoride, mercury fluoride, cobalt fluoride, antimony fluoride. Okay, in the place of NaI what you are taking, now here you will use this fluoride. Means suppose CH3 bromide is there, you want fluoride, methyl fluoride you want, and you have methyl bromide. You want methyl fluoride. Then AgF you can use. Anyone, either AgF, Hg2F2, cobalt F2 or antimony F3. Then now this methyl bromide CH3Br plus AgF, simple reaction, that F will come in the place of bromine. Okay, it will form CH3F and Br will go to Ag, that is the AgBr. Okay, then like that way this exchange can be done. It is easy method. Then now next class, now I am stopping only here. Next class I will start physical properties. Thank you.